This is a presentation on the MVC design technique presented by Casey Pye, Damon Simpkinson, and Thomas Whitelock for CS364.
My name is Thomas Whitelock, and I'll be doing this portion of the presentation. MVC stands for Model View Controller. The MVC model is also referred to as a pattern. The MVC model is used in many graphical user interfaces, which are also known as GUIs. Not to go into too much detail, but the MVC model has been around for a very long time. It was used in Smalltalk, one of the earliest GUIs. The first part is the model. It is the data that is used by the program. It is not always a database. It can be a file or an object within the program. The view is how the model is displayed. Examples are buttons, windows, or characters in video games. The controller, well, it controls and updates both the model and the view. It takes input and figures out what to do with it. All three parts are connected. The controller is the glue that binds them together. There are other models that can be used. However, the MVC model is very common and is supported very well in most IDEs. What is an MVC? Model objects are completely unaware of the UI. It does not matter to the data what the user interface is doing. The view is what is displayed on the screen. The view is also unaware of what the model is doing. The controller is what moves the data back and forth and determines where it needs to be sent and how things should be processed. One thing, there is not just one view controller. There is an instance for each element. If there are 20 buttons on the screen, then there will be 20 instances of the view controller. There are not 20 models. The controller knows what to send to the model and how and in which order it will need to be processed.
The MVC architectural model is separated into three components that work together. These are the model, view, and controller, as mentioned before. The model implements logic for application's data domain. It represents the data and nothing else. It is independent of the view and the controller. The model commonly stores and retrieves data from a database. When done correctly, a model class should be reusable without any modification. The view and the controller allow the model to be reusable. Should you need to port a program to a new interface, you'll be able to use the same model. Next, we have the view. The view displays the user interface. The view is directed by the controller, which can feed it data from the model. The view is the final product that the user sees. In a web app, it would be the page presented. Lastly, we have the controller, which handles the user interaction. It uses logic, but this should be minimal. It mostly lets the model data do most of the computing. It communicates with both the view and the model. When a request is received, the controller will process the request using the model and feed the resultant data to the view, where it will be presented to the user.
For an example, say I'm playing Zelda Breath of the Wild. I'm in the mood to take one of my horses out and explore the countryside. So I go to the nearest stable and fetch one of my faithful mounts. So far, so good. I now have my steed with which I can go exploring. By doing this, I manipulate the controls in which in turn fetch the object model for my horse. The controller knew how to fetch the needed data and send it to the view, which will display my horse on the screen. However, upon second thought, the countryside I would be going through is kind of rough and tumble. I should take the big horse instead. Once again, by me manipulating the buttons on the controller was able to process my input and fetch the big horse from the model. Once it is retrieved, then the controller can send the output for the view to display. As you can see, this is a much bigger horse, and I will be okay riding through the Bobkin on this magnificent steed.
Because the goal is to minimize coupling and objects in the MVC design pattern should have a narrow scope, they tend to be reusable. This is accomplished in part because there are few dependencies between the objects. This also allows programs using the Model View Controller design pattern to be more adaptable to change. When the change is targeted at one of the aspects of the MVC pattern, the other two are able to continue operation without any changes. This is all related to the separation of responsibilities where each function performs only its duty and does not overlap with other functions in the program. One problem with the MVC design pattern is that it is difficult to define, and as Fowler points out, is often misquoted and misunderstood. Fowler is one of the sources referenced by the Microsoft docs, but the point he makes is definitely valid and easy to see when comparing both the referenced Apple and Microsoft websites. One would think the design pattern would be a fairly straightforward concept, but as you review both sites, it is easy to see that these two computing giants cannot seem to agree on exactly what the MVC design pattern is. Another disadvantage of the MVC pattern is the steeper learning curve that comes with it. If you are working on all three aspects of the program, you will need to be familiar with all of the technologies that allow you to fulfill all three jobs.
The MVC model is a versatile software strategy. We recommend the MVC model for the following situations. First, when you wish to have parallel development with several developers without worrying that they will interfere too much with each other. We recommend this when you want to reuse code or port the program to a new interface. We also recommend this if you wish to manage project complexity in a logical manner. It is recommended where the user interface will be integrated with application domain or the data model. And if you plan to make any future modifications to your project, we recommend the MVC model. In conclusion, the MVC is a paradigm that separates the model, view, and controller components. This allows the code to be reusable and makes the program easier to maintain and build upon. MVC is highly adaptable to changing requirements and makes it easier for programmers to operate in parallel. With all the benefits of the MVC design technique, it is no wonder why it is used in so many places.